In part 2 of this unit on rational functions, what we are going to do is we are going to actually sketch the graphs of these rational functions. So in part 1, you learned most of what you already need to know. Now, all that we need to do is take all of that information that we solved for in that first lesson and actually put it onto our graph. So just like in the previous lesson, you're going to begin by finding your non-permissible values of x, which are going to indicate either a hole or a vertical asymptote. If there is a hole, you need to find its y value by substituting in the x value to the simplified equation. Then you're going to determine the equation of any horizontal asymptotes by looking at the degree of the top and the bottom. Then you're going to sketch those things, find your x and y intercepts, and then if you still need to find some more points to finalize the shape, you can do that as well. So in example 1, you'll see the first thing that I did was I factored the top, and in the bottom I factored out the negative. This allows me to see that there is a common factor of x minus 4. So because I have that common factor of x minus 4, it means that I have a hole at x equals 4. I then take that x value and plug it into the simplified equation. Now the thing you want to make sure of is that you don't forget about this negative. So the simplified equation is actually x plus 3 over negative 1. It could also just be written as negative x plus 3. When you plug that in, you get a value of negative 7. So the hole is at 4, negative 7. Now, when I go to look for my horizontal asymptotes, I can see that the degree of the top is larger than the degree of the bottom. But in this case, when I simplify my equation, I'm actually just left with x plus 3, negative x plus 3, which is linear. So in this case, the degree of the top is larger than the degree of the bottom. That's not one of the criteria that was listed on our chart from the first unit, and the reason that happens, or the times that that will happen for our purposes, means that you're actually just ending up with a linear function. So in this case, we just have the linear function negative x plus 3 with a hole in it at 4, negative 7. So you'll see what I did next was I solved for my x-intercepts. So remember, for x-intercepts, we're plugging in when y equals 0, solving for x, and when x equals 0, and solving for y. Once you have all of that information, you can plug those points onto your graph. So I've got my x-intercept, my y-intercept, and the hole, and I just connect them. So I have a linear function with a hole at 4, negative 7. Now for your domain and range, the only spot that is not included in the domain and range would be the x value of 4 and the corresponding y value of negative 7. So make sure that you're using round brackets since those points are not included. If I go to example 2, this is very much the same. It looks a little bit complicated, but the steps are the same. So the first thing that I did was I factored the top and the bottom. The top, there's nothing to factor, but the bottom can be factored to x plus 4 times x minus 2, which means I actually have two vertical asymptotes, one at x equals 2 and one at x equals negative 4. I then determined my horizontal asymptote. So in this case, the degree of the top is the same as the bottom. So it's the leading coefficient over leading coefficient, which equals 1. And I also determined my x and y intercepts. Now in this case, when I plug 0 in for y, I get an x value of 0, and when I plug 0 in for x, I get an a y value of 0. So my intercepts in this case are actually the same point right at the origin. So when you plug this in, you've got x equals 2 as a vertical asymptote, x equals negative 4 as another vertical asymptote, y equals 1 as a horizontal asymptote, and the only information you have is this point 0, 0, which is our x and y intercept. Now for this region down here, we know that the graph is going to curve towards the asymptotes. So we know that this graph is going to look like this. Looks like a parabola in between those two asymptotes. What we don't know is we don't know what the graph looks like to the left of this asymptote and to the right of this asymptote. So what we need to do is we need to choose an x value on either side and substitute those into our equation so that we end up with another point. So when I plug in x equals -5, which is just the next x value to the left of the asymptote, I get a value of approximately 3.57. When I plug in x equals 3, which is just to the right of this asymptote, I get a y value of approximately 1.29. So these 2 points I can plot on my graph here, and then I know this general shape is going to come down and curve towards the asymptotes. Now that you know what it looks like in all 3 regions, you can think of those as regions, you're ready to state your domain and range. So you have to jump over your asymptotes of -4 and 2, and also over the horizontal asymptote at y equals 1. Now, if we look at example 3, again, this is very similar. The first step is to factor top and bottom. So in this case, the bottom can be factored to 2x plus 3 times x plus 3. We have a common factor here. So we have a vertical asymptote at -3, but a whole at -3/2. Now, using my simplified equation, which is 1/x plus 3, I can plug in -3/2 to get a y value of 2/3. So this is the equation, the coordinate of the whole. Also, you'll see that the degree of the top is smaller than the degree of the bottom, which means we have a horizontal asymptote at y equals 0. And since y equals 0 is a horizontal asymptote, it means I have no x-intercept. There's no x-intercept on this line because it's an asymptote. But my y-intercept, I can plug in x equals 0, and I get a y-intercept of 1/3. So you'll see when I take this information, so -3/2 and 2/3, which is -1.5 and 2/3, there's a hole there, and then I can graph towards my asymptotes. And my y-intercept is 1/3, which is actually right on that curve as well. What I'm missing though is the left side of the graph. So I chose the point, or the value x equals -4. I plugged that into my simplified equation to get one more point of -4, -1, which allows me to plot a point there and also sketch towards my curve. Now in this case, I've got holes and asymptotes to deal with when I'm stating my domain and range. So for my domain, I go from -infinity. I have a gap at -3. The graph continues to this hole, which has an x value of -3/2, and then continues onward to infinity. And for my range, I go from -infinity up to 0. Then the graph extends up to 2/3, which is the y value of the hole, and then from 2/3 to infinity. So that's how you sketch graphs of rational functions.